There's something almost magical about biting into a perfectly ripe papaya, that sweet, tropical flavor that instantly transports you somewhere warm and exotic. But have you ever stopped to wonder how that delicate fruit, grown thousands of miles away in humid tropical groves, makes its way into your local supermarket looking absolutely flawless? The journey is far more complex than you might imagine. Behind those vibrant orange slices and convenient packaging lies an industrial ballet of precision, technology, and timing that would make a Swiss watchmaker jealous. Most people have no idea that the papaya they casually toss into their shopping cart has survived a gauntlet of quality inspections, temperature-controlled environments, and robotic handlers that would reject it in milliseconds if a single parameter was off. This isn't just fruit processing. This is agricultural engineering at its finest. What you're about to discover will completely change how you see this humble tropical fruit. The papaya factory isn't just a building where fruit gets sorted and boxed. It's a technological marvel where nature meets cutting-edge innovation, where ancient cultivation wisdom collides with modern automation, and where every second counts in the race against time and decay. The moment a papaya is harvested, an invisible clock starts ticking. Enzymes activate. Sugars begin converting. Cellular walls start breaking down. The factory exists for one purpose: to intercept that fruit at the exact moment of peak ripeness and preserve that perfection long enough to reach your table thousands of miles away. Inside these walls, you'll find systems so sophisticated they can detect ripeness levels invisible to the human eye, sorting mechanisms that handle fruit more gently than human hands ever could, and quality control protocols that would make pharmaceutical companies envious. The papaya industry processes over 13 million tons of fruit globally each year, and the factories that handle this volume operate with a precision that borders on obsessive. Because here's the thing most people don't realize: a papaya is one of the most temperamental fruits in the commercial food chain. Too firm, and it's inedible. Too ripe, and it turns to mush within hours. The window of perfection is measured not in days, but in hours, sometimes even minutes. What makes this even more fascinating is that papaya factories don't just process one type of fruit. They're handling dozens of varieties, from the small, intensely sweet Hawaiian solo papayas to the massive Mexican Maridol varieties that can weigh over 10 pounds each. Each variety requires different handling protocols, different ripening curves, different packaging strategies. And the factory must seamlessly switch between them, sometimes processing multiple varieties simultaneously on different production lines. This is industrial choreography at a level most people never witness. The hidden world of papaya processing is about to be revealed, and trust me, you'll never look at this fruit the same way again. Now, let's talk about something that will blow your mind. Papayas contain an enzyme called papain that's so powerful it's used commercially as a meat tenderizer. This same enzyme is actively working inside the fruit from the moment it's picked, essentially causing the papaya to digest itself from the inside out. That's why timing in a papaya factory isn't just important, it's absolutely critical. The fruit is literally racing against its own biology. Factory workers know that a papaya picked at the wrong stage will either never ripen properly or will turn into an overripe mess before it even leaves the facility. This enzymatic activity is also why you can't just refrigerate papayas like apples or oranges. Cold temperatures below 50 degrees Fahrenheit actually damage the fruit's cellular structure, causing it to develop strange flavors and never ripen correctly. Here's something most consumers have no idea about. The papaya you buy in the store has likely been harvested when it's still mostly green. That's not a mistake or a sign of poor quality, it's absolutely intentional. Papayas are what's called a climacteric fruit, meaning they continue to ripen after being picked. In fact, they ripen better off the tree than on it. If you waited for a papaya to fully ripen on the tree, the fruit would be too soft to transport, and that precious papain enzyme would have already broken down too much of the fruit structure. So factories have mastered the art of the harvest window, picking the fruit at exactly the right stage of maturity so that it will ripen to perfection during transport and shelf time. The global papaya industry is worth over $15 billion annually, and the majority of that fruit flows through highly specialized factories that most people will never see. India is the world's largest papaya producer, growing over 6 million tons per year, followed by Brazil and Mexico. But here's what's interesting. The papayas you find in North American and European supermarkets rarely come from India. Why? Because the varieties grown there are primarily for local consumption and juice production. The export market is dominated by countries like Mexico, Guatemala, and Brazil, which grow specific varieties bred for long-distance transport. These varieties have thicker skins, firmer flesh, and a slower ripening curve, all traits that make them factory-friendly. The Hawaiian papaya industry, once dominant in the US market, was nearly destroyed in the 1990s by a devastating virus called papaya ring spot virus. The industry was saved by one of the first commercially successful genetically modified fruits, the rainbow papaya, which was engineered to resist the virus. Today, most Hawaiian papayas are GMO varieties, though you'd never know it from looking at them. This scientific intervention literally rescued an entire agricultural sector from collapse, demonstrating how modern biotechnology can solve real-world food security challenges. Papayas are also incredibly nutritious, which is part of why they've become such a global commodity. A single papaya contains more vitamin C than an orange, more vitamin A than a carrot, and significant amounts of folate, potassium, and fiber. That same papain enzyme that causes such headaches for processors is actually beneficial for human digestion, which is why papaya has been used in traditional medicine for centuries to treat digestive issues. Modern research has confirmed what traditional healers always knew. Papain genuinely helps break down proteins and can ease digestive discomfort. The fruit also contains unique antioxidants called carotenoids, which give the flesh its distinctive orange color. One of the most surprising things about papaya factories is how they've had to innovate around the fruit's unusual characteristics. Unlike apples or oranges, which have relatively tough skins and can withstand significant handling, papayas are remarkably delicate. The skin bruises easily, and any bruise becomes a bacterial entry point that will cause rapid spoilage. Traditional conveyor belt systems with hard surfaces and sharp transitions would destroy papayas within minutes. So factories have developed specialized soft-touch handling systems using food-grade foam padding, cushioned rollers, and even water flotation systems where the fruit literally floats through parts of the processing line. The papaya's unique biology also creates fascinating challenges around gender. Yes, you read that right, papayas have gender. Papaya trees can be male, female, or hermaphroditic. Male trees produce pollen but no fruit. Female trees produce fruit but need pollen from male trees. Hermaphroditic trees produce both pollen and fruit and are self-pollinating. For commercial production, hermaphroditic trees are preferred because they're more reliable and produce more uniformly shaped fruit. But here's the weird part. A papaya tree's gender can actually change based on environmental conditions. Temperature stress, drought, or other factors can cause a hermaphroditic tree to temporarily produce only male flowers. Another mind-blowing fact: papayas are one of the fastest growing fruit trees on the planet. A papaya tree can grow from seed to fruit production in as little as 6 to 9 months. Compare that to an apple tree, which takes 4 to 5 years, or a mango tree, which can take 7 to 10 years. This rapid growth cycle means papaya orchards can be established quickly and start generating revenue almost immediately. But it also means the trees have a relatively short productive lifespan. Most commercial papaya trees are replaced after 3 to 4 years because their fruit production declines significantly after that point. Let's talk about something that sounds bizarre but is absolutely true. Papaya seeds are edible and have their own unique properties. They taste peppery, almost like a cross between black pepper and horseradish, and they've been used in traditional medicine as a treatment for parasites and digestive issues. Some cultures dry and grind papaya seeds as a pepper substitute. Modern research has found that papaya seeds do indeed have antimicrobial and antiparasitic properties, though you'd need to consume them in significant quantities to get therapeutic effects. The seeds contain many of the same beneficial compounds found in the fruit, just in much higher concentrations. The latex-like sap that oozes from unripe papayas is another industrial challenge. This milky white substance is incredibly rich in papain and other enzymes, and it can cause skin irritation in sensitive individuals. Factory workers who handle unripe papayas often wear gloves because repeated exposure to the sap can cause contact dermatitis. This same sap has commercial value, though. It's harvested from unripe papayas in some regions and processed into papain powder, which is sold to meat processing companies, breweries where it's used to clarify beer, and pharmaceutical companies where it's used in digestive enzyme supplements. The journey from tropical grove to factory floor begins long before the fruit arrives at the processing facility. Papaya cultivation requires specific conditions: temperatures between 70 and 90 degrees Fahrenheit, well-drained soil, and consistent moisture without waterlogging. Most commercial papaya farms are located in regions that naturally provide these conditions year-round. The trees are typically planted in rows with precise spacing to optimize sunlight exposure and air circulation while allowing mechanical harvesters access. Modern papaya farms use drip irrigation systems that deliver water and nutrients directly to the root zone, minimizing waste and reducing disease pressure. Harvesting is where the real skill comes in. Workers must identify fruit at exactly the right maturity stage, typically when the fruit shows the first signs of color break, meaning the skin is transitioning from dark green to a lighter green or showing the first hints of yellow. This is called color break stage 1 in industry terminology. At this stage, the fruit has reached full size and has begun the ripening process, but it's still firm enough to withstand handling and transport. Harvesters use long poles with specialized cutting tools to reach fruit high on the tree, carefully lowering each papaya to avoid bruising. These harvest bins are then transported to collection points, usually at the edge of the field, where the first quality inspection occurs. Workers trained in fruit grading examine each papaya for obvious defects: cuts, bruises, insect damage, irregular shape, or signs of disease. Fruit that doesn't meet standards is culled immediately. It might go to juice production or animal feed, but it won't enter the fresh fruit supply chain. The accepted fruit is loaded onto climate-controlled trucks for transport to the factory. This is where the cold chain begins, though cold is a misnomer for papayas. The trucks maintain temperatures around 55 to 60 degrees Fahrenheit, cool enough to slow ripening and reduce water loss, but not so cold that it damages the fruit. Upon arrival at the factory, the real industrial process begins. The facility itself is a carefully controlled environment, with different zones maintained at different temperatures and humidity levels. The receiving area, where trucks unload, is typically kept at 60 to 65 degrees with moderate humidity. The fruit bins are unloaded using forklifts equipped with specialized attachments that prevent jarring or tipping. Each bin is tagged with information about its origin: which farm, which field, what harvest date, creating a traceability system that allows the factory to track every piece of fruit back to its source. The first mechanical process is the initial wash. Papayas are gently transferred from bins onto a soft bristle brush conveyor that moves them through a water bath containing food-grade sanitizer, typically a chlorine solution at carefully controlled concentration. The brushes rotate slowly, removing field dirt, leaf debris, and surface contaminants without damaging the skin. The water temperature is precisely controlled. Too cold, and it could shock the fruit. Too warm, and it could accelerate ripening. After washing, the fruit moves through an air-drying tunnel where filtered, temperature-controlled air removes surface moisture. Next comes one of the most technologically impressive parts of the operation: automated optical sorting. Modern papaya factories use computer vision systems that photograph each fruit from multiple angles as it passes through the sorting station. These systems use advanced algorithms to analyze color, size, shape, and surface characteristics. They can detect defects invisible to the human eye: subtle bruising, early signs of disease, irregular ripening patterns. The system makes decisions in milliseconds, using pneumatic gates to divert fruit into different processing streams. For fruit continuing to fresh processing, the next stop is the ripening rooms. Despite being harvested at color break, papayas still need controlled ripening to reach optimal eating quality. The factory uses specialized ripening rooms where temperature, humidity, and even atmospheric composition are precisely controlled. Some facilities use ethylene gas, a natural plant hormone that triggers ripening, to accelerate and synchronize the process. The concentration is carefully managed. Too much ethylene causes uneven ripening and off flavors. The rooms are maintained at around 68 to 72 degrees Fahrenheit with high humidity to prevent water loss. After ripening, fruit destined for whole fruit retail sales moves to the packaging line. This is another area where gentle handling is paramount. Papayas are manually placed into mold cardboard or plastic containers that cradle each fruit individually, preventing movement during transport. Some operations use shrink wrap or stretch film to secure fruit in place. Each package is labeled with origin information, variety, and often a PLU code for retail scanning. The packaging must allow some air circulation. Papayas continue to respire even after packaging, and trapped gases can cause off flavors. For fruit being processed into fresh-cut products, the journey is different and even more technically demanding. These papayas move to a separate processing area maintained at lower temperatures, around 45 to 50 degrees, to slow bacterial growth once the protective skin is removed. Workers wearing gloves, hairnets, and clean uniforms manually peel and seed the fruit using specialized tools. Despite advances in automation, papaya processing still requires significant manual labor because the fruit's irregular shape and variable size make it difficult for machines to handle efficiently. Quality control checkpoints exist throughout the process. Random samples are pulled from every batch for laboratory testing. Technicians check sugar content using refractometers, measure firmness with penetrometers, and conduct microbiological tests to ensure food safety. The factory maintains detailed records of every batch, every test, every parameter. This data isn't just for compliance, it's used to continuously improve the process, identifying patterns and optimizing procedures. The waste stream from a papaya factory is substantial but increasingly valuable. Peels, seeds, and rejected fruit represent about 30 to 40% of the incoming fruit weight. Progressive facilities no longer simply discard this material. Peels can be processed into animal feed or composted for agricultural use. Seeds can be dried and sold to specialty markets or processed for papain extraction. Overripe or damaged fruit can be pulped and frozen for use in smoothie production or food manufacturing. The final stage before shipping is final inspection and cold storage. Packaged fruit is held in refrigerated warehouses at carefully controlled temperatures until it's loaded onto refrigerated trucks for distribution. The warehouse uses a first-in, first-out inventory system to ensure older fruit ships before newer arrivals. Temperature and humidity are continuously monitored, with alarm systems alerting staff if conditions drift outside acceptable ranges. Transportation to retail distribution centers continues the cold chain. Refrigerated trucks maintain the same temperature ranges used in the factory warehouse. Drivers are trained to minimize door opening time and to avoid routes with excessive vibration that could damage fruit. GPS tracking allows the factory to monitor shipments in real time, and temperature sensors inside the trucks record conditions throughout the journey. When you see papayas in your supermarket's produce section, you're seeing the end result of this incredibly complex industrial process. That perfect-looking fruit has been handled by dozens of workers, passed through multiple quality checkpoints, been photographed and analyzed by computer vision systems, spent time in precisely controlled ripening rooms, and traveled hundreds or thousands of miles in climate-controlled vehicles. The fact that it arrives looking fresh and tastes sweet is a testament to the sophistication of modern food processing and logistics. So the next time you slice into a perfectly ripe papaya, take a moment to appreciate the journey it's been on. That sweet, tropical flavor you're enjoying is the result of precise harvesting timing, sophisticated processing technology, careful quality control, and complex logistics. It's a fruit, yes, but it's also a product of modern industrial capability, a small miracle of agricultural engineering that brings tropical abundance to tables around the world, regardless of season or location. But papayas are just one piece of the global food processing puzzle. There's an entire world of factory processes that transform raw agricultural products into the foods we consume daily. Speaking of transformations, have you ever wondered about the thick, tangy sauce that defines American barbecue? That bottle of barbecue sauce in your refrigerator has its own fascinating industrial story. one that involves tomato processing, spice blending, cooking processes that would surprise you, and quality control that rivals pharmaceutical manufacturing. The chemistry of creating the perfect balance of sweet, tangy, smoky, and savory is far more complex than you might imagine. What is barbecue sauce really made of? Inside the factory where America's best sauces are made, there's a whole other world of industrial food production waiting to be discovered. If you found this journey inside the Papaya factory fascinating, make sure you're subscribed to this channel because we are taking you inside factories and facilities most people never get to see. We are revealing the hidden industrial processes behind everyday products, and trust me, there are so many more surprising stories to tell. What surprised you most about papaya processing? Was it the computer vision sorting? The controlled ripening rooms? The fact that papayas are harvested green? Drop a comment below and let me know what blew your mind. Thanks for watching, and I'll see you in the next episode where we uncover more industrial secrets hiding in plain sight.